in essence done in industry. We have our perspective and our parallel projection. Keep in mind that when I say parallel projection, that is synonymous with orthographic projection. So those are really the same terms. We went over this on Friday. Let's see if anybody remembers over a long weekend. What's the difference between these two projection theories? Cheryl?
Parallel, as you look at it, the lines are parallel and you actually have real measurements that correlate with that. If you are in perspective, the angles, as you look at it, it angles and
Right here.
everything is off. All your measurements are distorted. So you can't measure from that.
Yeah, the object's not shown true size, and it is in parallel. What drives that difference? And it's kind of a subtle difference, but it's an important difference, where this one, pretty much primarily everything is true size and shape. This one, nothing's true size and shape. What drives that outcome?
The infinite
Yes,
viewpoints.
What's that?
The infinite viewports of the observer.
Yeah. Okay. Where the viewer or observer sits, that's what drives it. Okay. Here, we define the location. Therefore, there has to be angles coming from here because we know where this person sits. Now, the further this person gets away, the less that angle becomes. And so for parallel projection, we say, okay, let's just move you back to forever. That's kind of another word for infinity. Then that angle gets smaller and smaller and smaller until it disappears. Therefore, our line of sights become parallel. That creates that true size and shape arena that we want to get into. Okay, so that's really the primary difference. One defines the location of the reader, one does not. Okay, it's at, well, it's defined, but it's at infinity. Now, as we come through here, there's a bunch of terms in the first couple of pages, and I think these are probably the best pictures to look at. So I'll just look at 10.5. So when we talk about orthographic projection, we have our object. We then have what we call a plane of projection. A plane of projection is an imaginary glass plate that sits between us and the object. In essence, it's what we were going to etch or draw our projection on. Next, you have your lines of sight. These are basically from our eyeball to the object. I kind of always try and think of these as little lasers. So when I look at an object, I can turn on my laser and kind of etch it in on that plate of projection. Any questions on those three terms? Plane of projection, line of sight, where the reader sits. In essence, that produces our orthographic view. Good. There's no problems with that then. Okay, after that, they go into, starting on page 493, our different planes of projection. But I'm going to skip over those figures and go right to page 499. Well, 498 would probably even be better. And we're going to talk about planes of projection. Now, when we talk about planes of projection, in essence, they're, what it is, the glass box that totally sits around an object, right? Yeah. That's what we do. We just take an imaginary glass cube, put it around whatever the object is. We call those our planes of projection. Now, there are really only 3 planes of projection, and they create 6 views. Now, the reason we want to go over these planes of projection is because the dimensions that are displayed with these planes of projection are important for us to know. So if you can look on here, you can see them labeled. There's a horizontal plane right here. We have a profile plane down here. And we have a frontal plane here. Now, the important thing to remember here, the frontal plane, that's where we look at the front of the object. Since it sits in a cube, this produces 2 views. It produces the front view and the rear view. Now, what dimensions go with these two, this plane, not these two, this one. So if I was to come in here and say, you know what, there's a couple dimensions that go with this on the frontal plane.
Height and width.
Okay. Yep, I've got height here and I've got width here. So all views that are created by the frontal plane will always show you height and width. This is our front and rear views. When I create a profile plane, or I do a profile projection, this one, again, has some dimensions that goes with it. It produces two views, the right and left. The two dimensions that we have on here would be height, one, and depth. So if you might have noticed by now what we're doing is we're really talking about three dimensions, right? Height, width, depth, and how we are going to describe them using orthographic projection. We do that through these planes. We have one other plane left that creates our other two views. This is a horizontal plane up here. And if I had to have dimensions on the horizontal plane, they would be width and depth. And that will create the top and bottom views. So the thing to remember when you're looking at these, whenever I'm looking at a front or rear view, I'm looking at frontal plane projection, I'm always dealing with height and width, always. I switch to a horizontal plane of projection, like a top view or a bottom view, I'm dealing with width and depth. If I get to the side of the object for a profile view, I'm looking for right and left sides, I now have height and depth. Now the reason I'm trying to go over this and spend 5-6 minutes on it and talk about it is that when you look at different multi-views, you're going to look at one and the next one, you need to in your mind say, oh, this view's got height and width, this view's got depth added to it. And you start making that connection in your mind without having to go to a sheet of paper and saying, oh, see, the left view has this, the right view has this. And it's just automatic as you look at it. So, 3 projection planes, 2 dimensions per projection plane shows an entire 3-dimensional object. Now, once we have this little glass cube that's imaginary, we've encompassed the object. We as a reader have sat here in the front and we got an infinity and we projected onto this view and then we rotated to the right, projected here, got on an airplane, looked down on it, and projected this view. We get all of these views etched into these glass boxes. We then unfold the glass box to create what we call a 6-view drawing. And this is on the next page. And they kind of show you the process. Where here they're starting to unfold the box and they put it into its final configuration down here at the bottom. Let's just do a quick drill here. I'm showing just the left side view. What dimensions am I talking about?
Depth and height.
Height and depth, because it comes off the profile plane of projection, correct? Here I have just the top view shown. Width and depth, because it comes off the horizontal plane of projection. See if I can get this better. You got to cover that one too. A frontal, so the front view. Height and width. Okay. So you want to start making those connections here. Now, when we talk about these 6 views right here, there are some things you want to keep in mind with them. One is the alignment of features. That's probably the most important thing. The front view, we talked about this way back in drafting 131. Every object has a front view. You pick it. You pick it based on 2 criteria. Do you remember what those 2 are? I'll remind you. As it's seen in production is number 1, right? Front view is as it's seen in production, so that a maintenance person can make that jump. Or if we don't know how it's used in production, then we put the hard geometry in the front view to make our life easy, namely circles, right? Because you start getting circles twisted and your life gets exponentially harder. So we want those in the front. So we pick the front view. Now from there, that describes height and width. Now from there, do we need another view? Technically, all objects require two views because they're all three-dimensional. Okay, there are some objects out there we do one-view drawings of, but they're few and far between. We'll get to those later. So technically, all objects require three views. Now, let's start with just these three right here that we call our three principal views. Notice how the features line up in them. So when I have this front view placed on a piece of paper, and I have the top and right side that go with it, if I find any feature on this object, I should be able to project perpendicular to it and hit that same object. So like, let's just focus, this right here is a center line. Okay? So it's showing the center of that hole right there. Now, if I take that and I was to just draw a line straight up, I need to hit that. It's got to line up exactly. When I take that top of that hole and I go this way, it's got to line up right with the top of that hole. We want to make sure we maintain this orientation. So somebody's sitting here looking at this right here and they say, I don't know what that is. Well, they can immediately come over and do this. Say, oh, that's it. And then they can bring it up this way and say, there it is right there. And then they can piece those three parts of that together to come up with the shape that's needed. In this case, an inclined plane. So the alignment of features is the first thing. You want all of this stuff to line up. The extent here should line up, the extent here should line up, this way, always. We do not change this orientation. If I give them a front and top view, it's front and top, and it's all lined up. If I give them a front and right, I give them that in this orientation, and it always lines up. I don't put a front view and then a right side over here, or over here. It always goes here, and it's lined up. So we always set these in this orientation. Is there any questions about that? So there's your alignment of features. Now with these same three views, these we call our primary views, front, top, right. Why do we call these our primary views? Because those three give us all possible combinations of the dimensions together. So remember, this guy right here, it's got x, y, or width, height. This one has z, x, or width and depth. And then this one over here, depth and height. Those are all your possible combinations. Generally, this is what the majority of your objects are going to be projected as three-view drawings. You will have some that come to 4 or 5 views if they got stuff in the back of it that you want to display. I've almost never done a 6-view drawing. In fact, I'm trying to search my memory for it. And granted, I'm getting older, but I don't think I have ever done a 6-view drawing because I have described the object before I get to those 6. Which brings me to kind of a caveat of our industry. How do I know if it's a 1-view drawing or a 2-view drawing or a 3-view or if it's all 6? The mandate you want to keep in your mind is you must completely describe the geometry and no more. So completely describe the geometry and no more. Now, the reason I say that is because we do not want to give them a view that doesn't give them new information. It takes a long time. We even went through that quote on Friday saying, hey, you have got to study these. They take time to visualize. And if we give them a view that doesn't add to the story, we're just slowing everybody downstream from us up. Because they're sitting there going, oh, I got this left view. What's it telling me? And they'll spend a lot of time looking at it and it's not telling them anything. Okay, so we completely describe the geometry of an object and no more. We just stop at that point. Okay, yes?
So my question, so on this drawing here, if that hole didn't go all the way through to the bottom, would you describe that on the front view and not making the line go through? I mean, how would you know that it was just bored partway? Would you tell them in the front view and by that
Okay,
line?
yeah, how do we know how the whole goes?
Or would you have to show the bottom view?
This describes the geometry of
Goes
it.
through.
One, we've got these hidden lines that are limiting elements. They aren't an edge, right? Those are limiting element lines, these right here. Okay, because that's where the cylinder would leave our line of sight. They go from top to bottom. This has to be a through hole.
There wasn't though, you would only have one dash in there?
Actually, you're kind of jumping into our third lecture here,
Okay.
but you do have what's called a blind hole, and it will look like this, okay? And it will look like that. We call this a blind hole. A blind hole is one that doesn't pass all the way through an object.
So would you have to show the bottom?
Oh, yeah. Oh, yeah. Yeah, we got to tell them the whole
Yeah,
stops, or
okay.
expect them to drill right through it.
Yeah, yeah.
And there's techniques we use in the dimensioning and display process to make sure that that happens.
And it doesn't require additional views.
No, no. Because one, if you take these each into it, let's just do that. Let's just do a little exercise. Break this thing down. Okay. So let's take this guy and say, how many views would we do for this object? Okay. Remember, the first caveat is take your object, break it into shapes. I see a rectangle right here. Okay. So right in this view right here, I've described the width and height of that rectangle, correct? What's missing off of that for somebody to build that? The depth. Okay. Where are they going to get that? Looks to me like they get it from right here. Okay. There's the depth of that same rectangle. We also find out that this end is a positive cylinder, and we're seeing a limiting element right here based on that. That's completely described. You've got height, width, depth of this rectangle. Now, let's look at the hole. Okay, in this view, we have the rectangular view of the hole. We find that it goes all the way through the object. Here we have the circular view of the hole, which gives us the diameter, or radius, right? Same size as a drill bit or something, so somebody can make this. The hole is completely described here and here. Okay. We now have another kind of rectangle. Let me deal with this two ways. There's two rectangles here. I'm going to do the big one right here. Here we see the width of it. We see the height of it. Here, we actually see the depth right there. That's completely described. The next part we have is this last rectangle right here. This one, we see the width, we see the height. Up here, you see it right here. That gives you depth. And it also gives you your width, but we don't have the whole story here. Based on these two views, since it is inclined, this is this top part, right? Foreshortened. That's foreshortened. That thing could still, at this point, be a circle. Okay, so it could come up, well, it could do this, or it could do that, or it could do that. It could do all of those based on what you see here and here. I have to provide this view only for one line. But I've got to give it. Okay. This is a 3-view drawing. These two views describe every piece of geometry except for that edge. And I'm going to give them a right side view to define that. And then it's a done deal. You'll have a key to this and know when it occurs a little bit later also. Once we put dimensioning in, you'll draw an object and you get ready to print it and you notice one object has no dimensions on it. It's probably not needed. Okay. That's just a fact, because we dimension the same way we draw. Okay, and that's a big key. Right now, what you need to do is look at every piece of geometry. Generally, it takes 2 views to describe any feature. And then you just look at how I'm going to get them. Yes, Becca?
So, like, say like the left side had a circle through it and the right side didn't. Would you leave the right side out and just use the left side? Or do you always have to?
I try and describe things with object lines.
Okay.
So if I see it with hidden lines, then sometimes I've got to make a case And let me kind of erase all my chicken scratches off of here. Okay. Now, on this case right here, so we've got hidden lines, right?
Uh-huh.
And an object line. So that's described because there's no way to get to this guy with the glass box. It's internal to the object. Okay, so we have to see it with hidden lines. Now, I think what you're saying is, let's say, what, you got a hole over here or something?
Yeah, like on the left side, like you have a hole. Yeah, like a hidden right there.
Let's say we got that little blind hole
Yeah.
that Mary brought up, and it sits right here.
I call you Mary.
So if I come to this view, how do I see this? It's going to be something like this, right?
Yeah.
It's going to be a hidden line.
And then in the front one, it wouldn't show.
Yeah, it would.
It
show in
would,
the front.
it'd be a
It's got to
header.
be in the front view. Okay. It's got to be in every view, right? So it's going to line up. It's going to be right there. On this one, I think since these are all hidden lines and I never see the circular view with an OBJ, I'd provide a left view. Just for that one feature right there. Now, I still have to provide this view for this, because if I go to the left, well, I see the left right there.
Yeah, that's what I was wondering.
Yeah, you're going to get a conundrum here.
Okay.
And the objects will do it. What we're going to do, this is a lot like what we talked about before. We're going to lay out guidelines. Try this, 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 and this. Here's standards. 6 views are a standard. Line weights are a standard. Okay, these are things that we need to do. But you will never have all these rules apply to every figure. Absolutely not. These are guidelines to get you started. At some point in time, you're going to come across a process where you have to, the term I use, you drop back 10 and punt. You don't know what to do. Keep in mind, there's a lot of ways to communicate. There's times when I've done this and I get it off and I say, you know, this is confusing as heck. I print it and I walk it out to the production floor and I go talk to the guy building it and say, here's what I'm trying to mean. Because we can communicate more than just figures here, right? Mm-hmm. We have a mouth, we have email. We're in a communication business. This will handle most of it, but will it handle all of it? No, no, it won't. But it'll handle the large part of it. Yeah, so in this case, what would I do? Oh, that's a toughie. To be honest with you, I'd pull out one of the sections that you haven't learned yet, and I'd get in the front top right. I'd put these 3, but I would use a process called a broken out section to describe that.
Okay.
So is it typical, I mean, you wouldn't just do front, top, and left. If you need a left, you're gonna give it the right anyway? Is it?
No, I'm not going to say that. I'm not
Okay.
going to say that.
Okay.
Okay. This is where we want to try and stay. That's your guideline. Try and stay here. If you need to delve outside of that, yeah, you have these available to you. Okay. Now, what you can't do is I can't do a front view and then throw this rear view without a left. Because then somebody's going to get confused and say, no, this is supposed to be a left. So they want to see a front, then a left, and a rear. Even if this one doesn't give any new stuff, I'm still going to do it.
So you wouldn't drop the front because,
No, every
I
object
mean,
has a
I'm
front.
sorry,
Yeah.
drop the right because you had the left over there.
Yeah, I could drop the right if I had to.
Do people who are looking at drawings feel more comfortable with the front, top, and right?
Yes, they do. Yes, they do. That's what they're used to. And keep in mind, this person building this stuff, they look at it, you know, maybe what, half hour a day? And then the rest of the time, they're actually constructing the object.
So you almost got an exception to the rule if you wanted to show the right and you needed the rear to throw the left in, even though it didn't show additional information.
Yes. Okay, so other things on the box to kind of point out. We got a couple definitions to go here. A new thing. These lines right here, that are around here, right here, we call these fold lines. And these guys right here are fold lines. These represent the edge of the glass box as you unfold it. So they represent where the planes are. Now you might think, okay, well, why are they on there? They're on there because we can use them to transmit dimensions between the two. Because if you think about it, I have these three views all lined up, right? Therefore, these three edges are all lined up. So if I know here, in this case it's width, from there to there, do I now know the width here? Yes, I do. I know the width here also. Now, do we see width anywhere else? No, I don't. But now if I take it from here and I measure this way to that object, that's my depth, right, from that edge? Well, that's also the same dimension as this one, from that edge to there. It's also the same dimension right here. Okay, they're all identical since we line everything up. So fold lines, we aren't going to use them right now, but later in the year, we're going to be using fold lines when we get into things called auxiliary views for oblique planes, these types of stuff. Okay. So fold planes, used to transmit dimensions in between objects.
But those dimensions would not be put on a final, like the,
No, you wouldn't have those dimensioned on a drawing, but you would use them to produce the drawing. Okay, now when we also talk views, we've got two other terms we want to make sure we know. Adjacent views and related views. These will transmit into a little thing I want you to look over later today. Adjacent views. What's the definition of those? Let me, instead of rewriting it, I'm just going to put it up here. Adjacent views. Two views placed next to each other which share a common dimension. Two views placed next to each other which share a common dimension. These definitions, by the way, are going to lead into techniques for drawing.